So I will record because I would like people that not the opportunity to join the session to get this session available in our YouTube channel. So welcome for the new joiner and feel free to share with us in the chat where do you come from. So those are fine. So I will start the presentation. So thank you for joining the session, and this session will be, the main topic will be a GitOps your Terraform configuration. And beforehand, I will, as you know, if you are usually connecting to this session, I will share with you some updates about HashiCorp products. So basically, I'm Stéphane, Este-Gracias, and I'm your host today for this session. I'm mainly open source advocate and cloud native transformation catalysts, and support as well talent and organizational development. So if you want to contact me, please use Este-Gra handle on social networks, and you can subscribe on our YouTube channels, HashiCorp user group Luxembourg, and find our previous recorded sessions. So let's start with the latest product news from our last meetup. So it was 2 months ago, just before the HashiCorp global event. So I will give you an overview on the latest news on each product. So first of all, the Terraform 135. So something no main release since the last meetup, and only a bug fix release. And Terraform Cloud introduced the run task on Terraform registry. So for Terraform registry, usually is an open repository where user can share and discover provider, modules, and policies to use in their own Terraform code. Now, run task have been added as another component so that a user can share and discover in that Terraform registry. For those that don't know what is run task, is some integrated, reusable, and tested third-party tools that can provide for you cost estimation, security monitoring, compliance check, drift detection, no-code provisioning, and more. You see some logos of run task provider here in the slide. So let's move on the CDK 0.14. Auto-generating the code binding for a large Terraform provider can take several minutes. So CDK-TF offer now to the pre-built provider packages that you can import directly into your applications. In that way, you have new provider grade commands, so you can upgrade, install provider bindings in your project. Select pre-built providers when installing a new project by the CDK-TF init command. When you launch a CDK init command, now it allows you to directly install the pre-built provider for the provider you select. More pre-built providers are available, so mostly all official Terraform providers are available as a pre-built provider. And improvement in the get command. So that means when you launch the get commands, it's faster now because existing bindings are not regenerated anymore. Concerning Packer, no release since the last meetup for Packer, and for HCP Packer, an introduction of ancestry features in beta. So ancestry refers to the relationship between source images as a parent and their downstream descendant as the children. So that means on the HCP Packer UI, you can now display ancestry statuses that warn you if an image was binned for an old version of one or more ancestor. So it's better like this to do security warning on images or children images. Regarding Console 1.14, so it introduced a simplified deployment architecture that eliminates the needs to deploy node-level console clients for Kubernetes. So the new architecture deploys a new console data plane component that is injected into a sidecar in the Kubernetes pod. So the data plane container, the data plane container image packages so the both envoy container and then this new console data plane binary. Then general availability of cluster peering model for connecting multiple data centers. This feature was first introduced in the previous version as a beta, so now it's generally available. And then the service mesh traffic management across cluster peers has been improved as well service failover enhancement. Then for Vault, so usually, as usual, Vault is the most active project on HashiCorp. So you have many new features on Vault. The most important one for the 1.12 release is the version plugin. So we, as Vault, add the concept of version 2 plugins. So making plugins version aware and enabling release standardization and a better user experience when installing or upgrading a plugin. So namespace custom metadata support has been added to specify custom metadata on namespace. Enhanced pass and role-based resources quotas with support for API pass suffixes and hot mount role has been added as well. The OIDC provider interface UI has been updated to ease the OIDC to set Vault as OIDC provider. Now, with a few clicks, user can now have a default OIDC provider configured and ready to go. Octane number challenge interface updates. On PKI secret engine, two features have been added on to support revocation workflow by using OSCP and Delta CRL revocation list. And by this way, the performance has been for the data transfer, the data transfer for revocation has been improved for this revocation workflow. Then additional telemetry metrics have been added as well for the PKI secret engine. Some new database secret engine have been added in that release secret engine, Amazon Elastic secret engine. This one is not quite new, but generates no static credential for existing managed role in Amazon Elastic Cache. The LDAP secret engine is not a new one, but is only unified. The two are related to the LDAP secret engine, the AD Active Directory secret engine then, and OpenLDAP secret engine. So both now are unified in the same secret engine. KMIP secret engine support for operation and attributes in the baseline server profile. PKCS, on the Vault PKCS provider added the ability to Vault as a secret engine to be used for PKCS 11. Transparent data encryption for Oracle and transform secret engine as a bring your own key workflow, add a support for backend for MS SQL server. Then Boundary improve PKI workflow workers and many UI updates have been added, and HCP Boundary is now has been announced during the HashiCorp Global in October as general available. So every HCP product is from the SaaS product from HashiCorp for remember. HashiCorp 1.4 introduced native service discovery support with health check and nomad variables, which lets users share this configuration variable across all the workloads on the nomad server. HCP Waypoint, no major release since last meetup, and HCP Waypoint, as the previous one, is been announced at the public beta during the HashiCorp Global in October. And then Vagrant, the journey to Vagrant 3.0 is ongoing. The Vagrant 2.4 is ongoing to replace the Go-based version for the primary executable that was available before. So now it's time for the main topic of the session. All this information I will share with you with an email after the session if you want to go deeper in that update. So now, Priyanka, the screen is yours. So welcome, Priyanka, and screen is yours. So I stop my screen, my share screen, and let you screen yours, share yours. Great.
Y'all can see it? Okay, cool.
Yes.
Okay. So yeah, thanks for having me. I'm going to be talking about how to achieve GitOps with Terraform and Flux. And so I'm going to start off with like giving a brief overview of what that is and what GitOps is, what Flux is, if y'all haven't heard of it before. First, my name is Priyanka Ravi. I also go by Pinky. And I am a developer experience engineer at Weaveworks. And before this, I worked at a large insurance corporation within the United States. And there I worked on the delivery engineering team. So we actually brought in GitOps to the company, and Flux was our choice for our Kubernetes solution. And so that's how I got started with Flux and GitOps and moved over to Weaveworks. And if you're not familiar with Weaveworks, yes, and I like modeling out my dogs in our swag. And if you're not familiar with Weaveworks, we're a globally distributed and remote workforce, and we do a lot of things that are based on open source. You might have heard of Flux and Flagger, which are in the CNCF. And we are really excited to announce that Flux has actually graduated within the CNCF. And so, if you're not familiar with the CNCF, that's the Cloud Native Computing Foundation. And we actually donated Flux to them. So Weaveworks created it and then donated it. And so, yeah, we're really excited about that. And then within, like, I think the next hour, the press release from, like, the CNCF and Weaveworks should go out about how Flux has graduated. So also, Flux is actually the project that really kicked off the term GitOps. Our CEO, Alexis, is the one that created the term GitOps. And then it's been really cool to see like the progress of all the adopters of the project and to see the community grow over the last few years. And also, there's a lot of cloud vendors, large cloud vendors, and other organizations such as like Microsoft, Amazon Web Services, VMware, and others that have adopted Flux and are using it under the hood to offer GitOps to their customers as well. And we have a bunch of other projects as well. So if you are interested, definitely check us out on GitHub under Weaveworks, as well as within the CNCF, where you can find our donated projects. And we also have paid products and services like Flux support. So if you're interested in learning more about those, please check out weave.works. So what is GitOps? GitOps is an operating model for cloud native applications such as Kubernetes, but it's not just limited to Kubernetes. And yeah, and sorry, just to address the questions thing. So if y'all have any questions, just drop them in the chat and I'm happy to be interrupted as well. So it's you don't have to just do it for Kubernetes. If you are doing like a multi-cloud infrastructure like I was doing back at the company I was at, you can still use GitOps, but especially with what we're going to be talking about in a bit with the Terraform controller as well. And GitOps utilizes a version controlled system. It's most commonly Git as the single source of truth. It's not required to be Git. You'll see that in a second too. I will mention that as well. Actually, we were just talking about earlier, we were talking about how like the new OCI support is really cool. But anyway, it also enables continuous delivery through automated deployment, monitoring, and management by a version controlled system. And managing your infrastructure and applications declaratively is how GitOps works. I will come back to your question, Anoop, when I get to. That's a little jumping the gun, but I will get to it. I swear. So anyway, I'm just gonna hit on the GitOps principles real fast. So the GitOps principles are like these set of best practices that have been put in place by the GitOps working group, which is a really awesome group that works with different vendors and user experiences. So they put together these principles based on users. And if you want to find out more about them, you can go to opengitops.dev, and they're always looking for like new participants to the group and everything like that. And I want to mention, don't feel like you have to have all of these met in order to start using GitOps. Everyone's journey really does look different, and you can start using GitOps and then add in hardening and tweak your setup to meet these guidelines as you go. But the first one is that a system managed by GitOps must have its desired state expressed declaratively. And so everything's written in code. It's reusable. You have an audit trail in Git. And yeah, there's a lot of benefits that come with code being expressed declaratively. Or state, yeah. And then the second one is that desired state is stored in a way that enforces immutability versioning and retains a complete version history so that there's no like sneaking in a change. Again, it goes back to the audit trail and all things like that. The third one is that software agents automatically pull the desired state declarations from the source. And the fourth one is that software agents continuously observe actual system state and attempt to apply the desired state. So the idea is you have an agent like Flux in this case that actually sits on your cluster and then is continuously making sure that what you have set in your source is what's actually out there. So why GitOps? As Kingdon said, there's lots of benefits of GitOps. There's the three value props of GitOps are security, velocity, and reliability, most importantly. And because of GitOps' unique way, like the tools' unique way to treat everything as code, that directly creates an impact on security. So if all configuration and security policy is treated as code, then everything can be held in version control. So any and all changes that are made are reviewed and they're actually, automated. So there's no manual sneaking in changes or anything like that. And with no manual processes, hopefully that, gets away from any errors or mistakes that can be made. So, less likely to be at work on a weekend trying to fix some release that was happening on a Friday. And also, all these things, stronger security guarantees, increased developer operational productivity, enhanced developer experience, improved stability, higher reliability, and consistency and standardization. So what is Flux? Flux is a Git-centric package manager for your applications, but like I mentioned earlier, Git isn't the only system that you can use. And it provides a set of continuous and progressive delivery solutions for Kubernetes. It was really created with Kubernetes completely in mind and the common Kubernetes tooling that's used. And so it's a natural extension of the benefits of Kubernetes. And at the core of it, what it does is it continuously monitors your version control system and it applies the desired state that's been declaratively expressed there. And the nice part of this is that you don't have to worry about configuration drift because it reconciles on a schedule. So if things have gotten out of hand for some reason, out of sync, whatever it is. If they've gotten, if some bad actor came in and deleted it, or if for some reason something, got messed up, it will actually set it back to the desired state. And also Flux really reduces developer burden because it also removes the need for manual deployment processes. Also, the Flux CLI, the command line tool, is a really easy way to get started using Flux. And we have a command called bootstrap, so you can just set it up really easily on your cluster. And it's a good way to access also the custom resources that make up the API. So, sorry, allergies. So these are some statements that we have on our website that we like to point out. And so I'm just going to briefly go over these. Flux provides GitOps for both apps and infrastructure. And you can also use something called Flagger. You can use Flagger in conjunction with Flux, and then you can deploy apps with canaries, feature flags, and A/B rollout, so you can do progressive delivery as well. And Flux can also manage any Kubernetes resource, and infrastructure and workload dependency management is built in. You just push to Git, and Flux does the rest. And it manages deployments through automatic reconciliation, like I mentioned earlier, and that's just the running on a cycle loop, and it will make sure everything's set up. Continuously pull. Flux works with your existing tools. It works with your Git providers as well, so it works with GitHub, GitLab, Bitbucket. You can even use S3 compatible buckets as a source, OCI, Helm repositories, etc. And also all major container registries and all CI workflow providers as well. And then it also works with any Kubernetes and all common Kubernetes tooling. Like I mentioned earlier, it really was created with, like your existing setup in mind. So it works with Kustomize, Helm, RBAC, and policy-driven validation, such as OPA, Kyverno, admission controllers, etc. There's a bunch that it works with. And Flux does multi-tenancy, and as like we like to say, multi-everything. It uses true Kubernetes RBAC via impersonation and supports multiple Git repositories as well. Multi-cluster infrastructure and apps work out of the box with Cluster API. Flux can use one Kubernetes cluster to manage apps in either the same or in other clusters, spin up additional clusters themselves, and manage clusters including life cycles and fleets. It also has alerts and notifications. It can provide health assessments, alerting to external systems such as Slack, other chat systems, and external events handling as well. So basically, you could just get push and get notified in Slack and other chat systems when the change is picked up. And then users trust Flux. Like I said earlier, I was actually the way I got started with this is by being a user myself, an end user. And then I really liked this product so much that I wanted to come, work with it. And then also the community is really awesome. I've really enjoyed working with this community. And we welcome contributors of any kind. The components of Flux are on Kubernetes core controller runtime, so anyone can contribute and its functionality can be extended very easily. Okay, so the benefits of Flux, one is that it reduces developer burden. It removes the need for kube control can kind of be an issue. Like you don't have to worry about kube control versions to be able to interact with the cluster. It's also extensible, so it's really versatile. It works with existing tools. It's really flexible, so it's modular and like I mentioned, it's a natural extension of Kubernetes. But because of the microservice architecture, you can really pick and choose what you want to use to tailor your own experience as well. And then, so this is an overview of the architecture of Flux. So Flux is actually a set of Kubernetes controllers. And if you're not familiar with controllers within Kubernetes, a controller handles the lifecycle of objects, basically what should be done when an object is created, deleted, etc., updated, whatever. And so in here you can tell, so we have within Flux itself, within the Flux project, there are the source controller, customized controller, Helm controller, notification controller, and then the image controllers. And I'll go into depth with about like a little bit about what those are, but I just wanted to mention here that we also now have, so the Terraform controller is not actually part of the Flux project, but it's an open source, it's a free and open source tool that was created by Weaveworks that's in a separate repository. We also have the VS Code extension now, so that's a really neat way if you're using VS Code to, it's a really good developer tool to be able to see what your current setup in your cluster is for Flux, and then you can actually interact with your Flux sources and syncs there as well. So. Okay, so what do the controllers do? The source controller actually fetches resources and stores them as artifacts. And so it's basically the one that's continuously listening to your Git repository, your OCI repository, whatever source you're giving it, and it continuously pulls them in. And then the customized controller is the one that actually applies those manifests, and it runs manifest generation using customize. So the reason it's called the customized controller, because I know this can be a little confusing, is because it's actually using customize in the background. So if you have a customization.yaml in your folder that you're pointing to, it will just by default pick that one up and apply whatever you've set in there. So whatever your customization.yaml says, right? But if you don't have a customization.yaml file set, it will go through and whatever folder you've given it, and it will actually just like recursively pull whatever manifests are located in there and then apply them, whatever YAMLs. So that's how, it basically is creating its own customization. It is creating its own customization.yaml in the background if you don't have one. So that's why it's called the customized controller. Then we have the Helm controller, which actually manages the deployment of Helm charts. And then we have the notification controller, which specializes in handling inbound and outbound events. So that's the one that's doing all those notification and alerting. And then we have the image reflector controller, which actually reflects image metadata for the automation controller, which then updates YAML when new container images are available. So basically those two work together to update a Git repository when new container images are available. And it works with like a ton of other tools. Basically I just listed some of them here, but there's a lot. So yeah, and then I just wanted to hit on why I, as a user, really loved Flux and why other people I've heard love Flux. So it really just makes life easier without having to do manual deployments or worry about pipeline processes. And then also multi-tenancy is really awesome. I didn't mention it at all here. I mentioned it briefly in the statements, but if you are doing multi-tenancy, it's really awesome. You can do multi-cluster. You can also do soft multi-tenancy with namespaces, which is what I did in my experience, and it's really easy to do within Flux. Also, depends on is a really neat feature. If you have, let's say, something that needs to be stood up before the other thing, you can do that as well with depends on. And then Helm integration is fantastic with Flux. It works really, really well natively. The notifications and alerts are really easy to set up. I'm going to actually show it in the demo too. And then Bootstrap, like I mentioned, is a really easy way to start using Flux right away inside the Flux CLI, which is a really user-friendly CLI that I think is one of my favorite CLIs I've ever used as an end user, because it tells you all the, let's say you need help with the CLI and you do a help command, it'll even give you the commands to run. And then it also gives you a description of it. So it's really very user-friendly. And then also now the Terraform controller, which is really awesome. So going into the Terraform controller. The Terraform controller is a free and open source Flux controller that can manage Terraform resources. Like I mentioned earlier, it doesn't come with Flux installed, and it's not part of the actual Flux project, but you just have to install it separately, and I'm going to show how to do that. So I use the Helm chart to install it. And then also Terraform resources that can be managed are not limited to Kubernetes resources. It can manage whatever you're terraforming, basically. And these are the links to the Terraform controller on GitHub. There's also the Terraform controller docs. Thank you, Vanessa, for sharing that. And then also I just wanted to mention that there's this within the Terraform controller docs, there's a use cases page, and within that page, it's really well laid out of like all the different things you can do with the Terraform controller, all the features, and it gives you examples on actually how to use them. So the benefits of the Terraform controller are that you have full GitOps automation. So you get all the benefits that I mentioned earlier with GitOps. You can GitOps for existing Terraform resources. There's the GitOps model for plan and manual apply. If you want to with Terraform, you don't have to automatically apply it. And then also there's the drift detection of Terraform resources, which I'll get to in the next slide. But and then basically it can be used as a glue for Terraform resources and Kubernetes workloads as well. Okay, so the features of the Terraform controller. So these are maybe, besides just, the ability to use GitOps now, these are also really awesome features of why to use the Terraform controller as well. So the first one is that now you can actually, not now, this was one of the earliest features, but you can set up manual and auto approvals. You can, let's say you don't want it to actually, so like with the idea of GitOps, right? You have something that's continuously listening and then automatically applying it. But with Terraform, that's not necessarily how we do Terraform. A lot of times you want to see the plan and then make sure it's what you want and then apply it. So you can do manual approvals, set it up to wait for you to check out the plan and then actually commit back to approve it. And I'll show that too. But the next one is drift detection. So this one is really cool because let's say you're using pipelines and you don't want to switch over yet. That's fine, right? Totally understandable. But you can still set it up to listen to your repo, and it will check live state. So even if you don't want it to actually apply anything, it can actually still send you notifications to Slack to tell you, hey, this has gotten out of sync. And then you can even go in and manually, fix it. or run the Terraform apply again. So that's a really neat feature that, is set up there. Because the thing about pipelines, right, is that it's a one-time push. The idea of the push model versus the pull model is one that's been talked about a lot. But with pipelines, you're doing the apply one time, right? It's not continuously checking and making sure that your live state is what's actually expressed declaratively in your code, in your Terraform. So also it accepts a list of config maps and secrets as variables. And this is this is kind of confusing. So the default action of the Terraform controller is that the state file is stored in a secret in Kubernetes, but it's very easy to set up the backend to tell it to, store the state file elsewhere. It also works with Terraform Cloud or Terraform Enterprise as well to store a state file. Whatever you're doing, you can continue doing it. So if you're using S3 buckets to store your state file, you can continue doing that. If you're using Terraform Cloud, you can continue doing that, Or if you're just trying to play around with it, have it set the state file in a Kubernetes secret. That's, when I run my demos, that's how I do it, unless I'm using Terraform Cloud. And then it has health checks as well. This is a really cool feature. Check out the documentation to check out how to set those up. But yeah. And then you can, I'm going to skip dependency management for a second. You can destroy resources on deletion. So this isn't the default action. You can set a flag to allow it to destroy resources if the Terraform object also gets deleted, but that's not the default action. And then you can write outputs to a secret, and you can, so one of the more recent things that we added was concurrency to allow it to be greatly scalable. So the performance really has improved significantly. It was recently tested with 1,500 Terraform modules. So it uses runner pods now to be more scalable. So you can actually customize the number of runner pods that it's using. If you need more Terraform modules to be run synchronously, or if you want, and because of that, you can actually customize them to include a specific image or whatever you needed to customize in the runner pod as well. And then also, you can use OCI artifacts as a source. Flux added that earlier this year, so Terraform controller was quick to follow, adding OCI support as well. And then you can force unlock the Terraform state if you find yourself in that situation. And the most recent one is dependency management. So that was within the last, I think, week and a half or so. And that allows you to actually say, I want this to be stood up, and then I need to use the output from that one in this other module. So that's a very exciting feature that, Terraform by default doesn't allow, so doesn't support. And so that's a really cool one that you can use it for. We're very excited about that feature. Okay, so now I'm just gonna show the Terraform controller in use. I have a pre-recorded demo that I'm gonna show. It's just gonna show, I'm gonna show very simply how to set it up, and then how it works in use. So I'm gonna set up an instance of Vault. So I have this Flux Vault demo project that my coworker Russ created, and it basically just has a makefile in it that sets up, it first runs a, create cluster. So it's using kind, it's creating a kind cluster, and then it's bootstrapping Flux. So this is that bootstrap command that I was talking about earlier. That's really easy to get started. So what bootstrap is doing is it is connecting to this repository. And so if this repository already exists, it's going to bootstrap into that cluster, into that repository, and then and with that, whatever that path is. But if the repository doesn't exist, it will actually create one. And so that's why it needs that token and everything. And so it's also to push back to Git, right? And so if it doesn't exist, it'll create it. If it does exist, it'll just bootstrap into it. And if you've already bootstrapped and then you rerun bootstrap later, with a new Flux CLI version, it will actually upgrade your Flux manifests to the updated version of Flux. So it's a really easy way to also then go back and update Flux. So now that's run, that command has run, and you can see that it stood up these controllers. So yeah, I don't know why this is cutting off a little bit. 1 second. I guess it's not that bad. But yeah, so within the repo, it created these, let me go back a second. It created this clusters kind folder. Well, in this case, we already had it, but if it didn't exist, it would create this clusters kind folder, and within it, it would create this Flux system folder. And Flux system is the namespace that gets created for storing all the stuff for the Flux controllers and everything for the Flux setup. So this file here called the GOTK-components YAML, it actually it has all of the manifests that are necessary for Flux to run, including custom resource definitions, and all of the actual pods for the controllers. And then this GOTK sync is actually setting up Flux to point back to itself, to point back to this repo. That's how it, stays updated. And so this source at the top, this Git repository source, is how you set up Flux to listen to whatever source it is. In this case, it's Git repository, right? And so we're saying so listen to this Flux Vault demo, and then every 1 minute, so this interval is telling it how often to actually go in and pull in any manifests that have been pushed. And then the customization is saying, specifically in this clusters kind path, apply what's in that folder path. And like I said, it's looking for customization.yaml by default, but it's also going to apply every 10 minutes. I may have, okay, so yeah. And then I also have this apps.yaml file in here, and this is pointing, so this is adding another customization because we already have that source that's pointing to the whole repo, right? This is adding another customization that's specifically listening to this base apps folder and applying it every 10 minutes. And so within that base apps folder is where we have the actual setup for TF controller. And like I said, I'm using the Helm chart. So this is actually how you tell the source controller to listen to a Helm repository. So in this case, it's listening to the TF controller Helm repository, and it's pulling that from that source every 5 minutes. And then we have this release.yaml, which is how you set up a Helm release to tell the Helm controller to then go and apply this Helm chart. So this is saying, it's the TF controller chart, and then every hour go and make sure the Helm chart's, up to date, and it's this values section is how you pass the values. So in this case, concurrency is set to 24. If you're familiar with Helm charts, then that doesn't look too unfamiliar for you. And then in this one, we're creating a Vault namespace, and we're setting up a Vault instance very similarly with a Helm release and a Helm repository as well. So just setting up a base Vault instance. And then in this demo, we'll use Terraform basically to manage that Vault instance and also add a secret and all that kind of stuff. So this is key here. Like I said, I'm going to be showing the notification controller and how the drift detection works. So I'm setting up this Slack webhook secret. Don't push this secret to Git because Slack is really smart. If it's a public repo, at least, it will delete the webhook from the website. And I learned that the hard way. I was like, why does my webhook keep disappearing? Slack is very smart. So I created that secret for it. And then I'm going to add into this customization.yaml back this Terraform notifications. And so this is very key. What I'm doing right here is really important because this is a patch to the CRDs. This is telling, so the notification controller by default is only going to be listening to, Flux events. So things that Flux is aware of. Well, Flux isn't aware of the Terraform controller and the Terraform events, right, by default. So this is telling it to also go listen to Terraform events as well. So this is very necessary in order to make this work. So I'm going to add that change. Okay, so, and then what that did is in here, this Terraform notification, notifications YAML, so the provider at the top is actually saying, hey, the provider is Slack, and go listen to that Slack webhook name. And it's also got the channel that I've created, you know, and then the alert is actually telling it to go listen to alerts, to notify on alerts, like with anything with the name Terraform. So just notify me on any Terraform events, basically. Okay, so then this is how you actually set a Terraform object. So I think I changed my mind and didn't feel like, yeah, I changed my mind and decided to use the UI. I remember this. And so it's basically saying that, let me skip ahead a little. Okay, so what it's doing is, this is how, you remember how I showed like the how to set up a customization to apply that, and then how I showed like the Helm release to set up, to deploy to Helm. This is telling the Terraform controller how to act, like what to actually apply within the Terraform. So in this case, it's saying apply what's in this K8's vault config path, apply the Terraform that's there, and apply it every 1 minute. And then so you see this approved plan is blank in this case. If I wanted it to apply automatically, then I would put auto in that string. But because it's an empty string, I'm telling it to apply manually. And line 25 is telling it to store the readable plan as human. And so what I'm saying is I want to, it'll store it as a config map, and I'm telling it to store it as like what we're used to seeing Terraform plans look like, right? With the plus and everything. So that's what's happening in there. Okay, so in the path that, you know, we've pointed it to, the Terraform path, this is what's there. So like I said, it's just, you know, setting up all it's doing a lot of the setup for Vault, the back end, and then it also, oh, I think I breezed past it real fast. It also has this, this secret that gets created here. So if you look, there's a demo secret here that gets created within the demo path, a secret that gets created here called demo, just creds, and it's got just demo as the username and my password is the password. But I'm just showing it as an example of an object that I can, you know, show with drift detection. So if we go in here and actually reconcile. So reconcile, like I said, is how you tell it to go in and like sync and pull and make sure everything's applied. So what this is doing is this is pulling in the new source, and with the source controller, if the source controller actually pulls in a change, it will also kick off to the customization controller and tell it to go and apply the change. So in this case, I don't need to run both, reconcile both. But you can see here that I now have this, well, sorry, I was on the wrong one. Now in this general channel, because remember that's the channel we set it up to listen to talk to, we can see that it has created this plan. And it says plan generated, set approved plan to this string to approve the plan. So that's how we can, that's how we approve the plan if we're doing manual apply. And before I do that, I think before I commit it, so if I committed this, right, it would actually approve it, but I want to show the output of the plan first. So in order to output the plan, we just do a get config maps, and then we output it as a YAML. So we'll give it a second. Okay, so If you're familiar with Terraform, you're very familiar with a Terraform plan and what it looks like. So it's just a very human readable Terraform plan that gets output into that config map. So we like what we see. It's standing up everything from scratch. Like it's all pluses because it's just doing it for the first time. So I went in and I made the change and I added that plan like I approved the plan by putting that string in there. So now if I reconcile it again, it should pull in the new config shot, the commit shot, and then it will actually apply it. So we got to give it a second though, because Terraform plans do take a minute. So we got to give it a second. So now it's initializing. And if we go back to Slack, we can see that it actually notified us that it actually applied successfully. So that's awesome. And then we're going to skip a little bit. Okay, so what I just did is I set it to auto to just, approve the plan, and I got rid of store readable plan. So in this case, it's just doing automatic applies. So like the, traditional GitOps way. And then going to apply that. And okay, so what I did here is I'm going into the Vault instance, local instance that I've stood up in this demo. And then I'm actually going to I'm showing you that there's there. And then I'm just going to go in and I'm actually going to delete this secret, be the bad actor myself of showing like what would happen in the case of configuration drift. And then you can see here that it does notify you within Slack, and it says, drift detected, objects have changed outside of Terraform, and it shows you exactly what has been deleted. So in this case, it's saying like this secret has been deleted, which is a pretty powerful thing. So like I said, even if you're not using the Terraform controller to actually do your deployments, you can still set it up to notify you. And this is like a good thing to know, like, hey, for some reason, something's gotten out of sync. And then you can go handle it yourself, if that's your chosen path. And as you can see, with the auto apply set up, it's already back up, and the secret's already stood back up because it handles configuration drift in that situation. And that is it for my demo. So yeah. Are there any questions?
So thank you for this great presentation. So let's see if we have any questions. So probably I see all the questions have been already answered, I guess.
Yeah. How does it work with Argo CD? Okay, so so there is a tool called Flamingo within Kingdon's actually my teammate, so he's like there's actually a tool called Flamingo that the same guy who created the Terraform controller within Weaveworks actually created as well, and it is a Flux subsystem for Argo, and basically it allows you to use Flux within your Argo setup, and in turn you can also take advantage of the Terraform controller as well. So let me find a link to it real fast, and then I'll drop it. Okay.
Right. Thank you, Vanessa, for sharing all the links on the chat.
Yeah, she's awesome. And then I think I answered the other one. Why would you need Terraform controller in GitOps? We can do it with regular. Yeah. So if I didn't clearly answer that, basically the idea is that there's the continuous reconciliation, pull model versus push model. It's everything's in one place. I hope I answered that question through this presentation, or else I didn't do my job properly. Is it an alternative to Helm? So I think I already answered that too. Like basically that it works really well with Helm, but it's not an alternative to Helm. It just, can take advantage of Helm. And then I'm not familiar with Anthos. I'm sorry. I saw that question and I was like, I'm not going to be very helpful with that. So, I think you meant Argo? No, I don't know. No, maybe you meant Anthos, but I don't know that one. If you did, sorry, can't really help. Does it have compliance reports? No, it doesn't. So, like I said, we were using, we had some other stuff that we were using. Basically, I'm not sure what you mean specifically by that, but I don't think so. No.
Or probably if you want to have some compliance reports with Terraform, if you use Terraform Cloud and run task with the dedicated tools to do compliance task, probably compliance report, probably you can have this. It's only a guess because I don't know.
That's a good point. Yeah, Terraform Cloud is great. We actually are working with HashiCorp a lot to work on Terraform Enterprise and our own enterprise working together. So yeah, we made sure that this works really well with Terraform Cloud and Terraform Enterprise as well. For example, if we are deploying platform Terraform code regularly via yeah. Let me find it.
Yeah, it means many things. So.
Okay, I could have sworn there was a how to use a notification controller, but now I'm not finding it. So maybe maybe it's not documented. If it's not, I will work on adding it. But hopefully it helps seeing it. Yeah, you would need that file. So I thought it was somewhere.
Yes, for the last question about the cost estimation, as I shared during the product news, you can use the run task with the cost estimation modules during the Terraform plan. And also run task is basically a webhook that call an external tool. So whatever tool you want to connect, you can connect on it. So there are already integrated third-party tools for run task on Terraform Cloud. And you can connect the cost estimation during the Terraform plan.
Yeah. Yeah.
We'll have a look on run task in Terraform Cloud if you want to go deeper.
In Terraform Cloud, we have TF controllers. Not within Terraform Cloud, but you can set within the Terraform controller. You can actually set up TF. You can set up Terraform Cloud to work with it. I think. Let me find.
Yes. Next question. Terraform Cloud has a dedicated Terraform provider to operator on Kubernetes to do such Terraform run inside the cluster instead of doing in the SaaS environment. But it's not linked to what we did. We saw today. It only apply the configuration when you use the Terraform Cloud UI.
So I have this. This shows. This is saying Terraform Enterprise, but it's the same setup for setting it up for Terraform Cloud as well. So if you do want to use that.
Feel free to ask questions if you have some on the chat. We have 5 minutes more.
And I will, I'll look into setting up adding the how to set up the notifications. Sorry about that. I don't see it. Maybe I'm missing it too, but I doubt we're both missing it. Maybe we just forgot to add it. but yeah.
So continue to ask questions on the chat, and before closing the meetup, I will share with you all the next events related to HashiCorp User Group Luxembourg. So first of all, is the 10-year anniversary of the community HashiCorp User Group. Is on December 13 in person. So it will be Ask Me Anything sessions, cake, drinks, and surprises. You can, if you are in Luxembourg, feel free to join in person, but as well, HashiCorp will have a virtual event in as well to connect on if you want to see it. But feel free to join in person. For the next event, they are all virtual. The HashiTalk, Benelux, France Deploy, and HashiTalks. Here you have all the dates. So the 1st December for HashiTalk Benelux, HashiTalks deploys on the 7th and 8th, and HashiCorp France January 26th, and HashiTalk February 16 and 17 as well. So feel free to have a look on and register in them. And for the HashiCorp User Group Luxembourg next year, we'll have another session dedicated to a product from HashiCorp. The one for the December 13th will be watch party for the Ask Me session and surprises, and as well networking and have a good time with cake and drinks. So feel free to join. Thank you very much for attending the meetup. Thank you for you, Priyanka, to be there and a great presentation. And as well, a special thanks to Vanessa to share your links as well in the chat. Stay in touch and hope to see you in next meetups. If you want to stay a bit more during the session, we can have open discussion afterwards. And please, you can as well have a look on YouTube channel and or share with your colleagues or whatever people you want to know what you see in the session and cannot attend this one. Go to the YouTube channel to get the record session. So thank you very much, and you're welcome to ask question more or stay here to discuss about whatever question on HashiCorp product, etc.
I don't know how I would share the slides. So, do you
Please
want like a
sharing.
link and then you can add it maybe to the meetup? I don't know how that works.
Yes, if you want to share the slide, I can. Usually, I'm using. I don't remember the name of the tools. You can share with me the
I'll
PDF,
share it with you.
and I will share with all the people.
Okay, cool. I'll send it to you and then you can share it out.
Yes.
And then Anoop, your question about the prod thing. So the Terraform controller is like fairly new. It pretty much like took off this year. No, it did take off this year. So, I don't like. I know a lot of people are using it. I don't know for sure if there's a lot of people in prod yet. We have someone who we work with very closely that I know has been working on at least getting it set up at his company. And so I don't think he for sure yet has it, but he's done a lot of talks too. His name is Robert Strand. And so, yeah, I'm not sure. I don't know. That's something I'm still like waiting to hear back a lot of feedback from, but mostly it's people like, still getting started with it. So Terraform controller will recognize all our Terraform scripts. Yeah, as long as you point it to that folder. Yeah, it'll recognize whatever your Terraform. Yeah, exactly. Right. Yeah. Terraform scripts and modules. Exactly.
So very interesting and promising project.
Modules. Yeah. So I recommend don't use the default backend. Use whatever backend you're using for sure. A Kubernetes secret couldn't handle that much of a backend or of a state file. So, yeah. We have played around with it with GCP and stuff. Yeah. So you're good. Yeah. It is fantastic.
Yes, because by default the backend is a secret from Kubernetes, and you have a limited size of secrets. So.
Yeah. Kubernetes secrets obviously are, limited. So I got that question a lot when we were at KubeCon, and like I think it wasn't really clicking that it doesn't need to be stored as a Kubernetes secret. And I was like, no. Whatever you're using currently for your state file, just keep using it and set it up as the backend. It's fine. So yeah. I like to emphasize it now because I'm like, I don't know if I'm explaining it. Yeah.
Thank you for joining as well.
Thank you for having me. I don't know if there's any other questions.
I don't think so.
No, maybe not.
So thank you very much, everyone, and see you on the next sessions. And another big thank you for you, Priyanka and Vanessa, as well for this session. Very inspiration about how to use Terraform with the GitOps way of working, and many use cases that not so easy to do with the Terraform in the pipeline. Could be suddenly easy to manage, especially the detection, auto create or auto configure, auto provision tools like Vault, like this. It's very efficient. Yeah.
Mm-hmm. I guess we'll end it, I think.
Yeah, so I will stop the record if you want to stop.
Thank you so much. Bye.
Stop recording.